हेलो फ्रेंड्स, वेलकम टू माय चैनल। आज के इस वीडियो में हम क्लास 10th के साइंस चैप्टर 4 कार्बन एंड इट्स कंपाउंड्स चैप्टर पढ़ेंगे। इन द लास्ट चैप्टर वी केम टू नो मैनी कंपाउंड्स ऑफ इम्पोर्टेंस टू अस। In this chapter we will study about some more interesting compounds and their properties. Also we shall be learning about carbon, an element which is of immense significance to us in both its element form and in the combined form. Activity first. Make a list of 10 things you have used or consumed since the morning. Compile this list with the list made by your classmates and then sort the items into the adjacent table. If there are items which are made of more than one material, put them into both of relevant columns of the table. Look at the items that come in the last column of the above table filled by you. Your teacher will be able to tell you that most of them are made up of compounds of carbon. Can you think of a method to test this? What would be the product if a compound containing carbon is burnt? Do you know of any test to confirm this? Food, clothes, medicines, books, or many of the things that you listed are all based on this versatile element carbon. In addition, all living crust and in the atmosphere is quite meager. The earth crust has only 0.02% carbon in the form of minerals like carbonates, hydrogen carbonates, coal, and petroleum. And the atmosphere has 0.03% of carbon dioxide. In spite of this small amount of carbon available in nature, the importance of carbon seems to be immense. In this chapter, we will know about the properties of carbon which make carbon so important to us. Bonding in carbon, the covalent bond. In the previous chapter, we have studied the properties of ionic compounds. We saw the ionic compounds have high melting and boiling points and conduct electricity in solution or in the molten state. We also saw how the nature of bonding in ionic compounds explains these properties. Let us now study the properties of some carbon compounds. Most carbon compounds are poor conductors of electricity, as we have been in chapter 2 from the data given in table first on the boiling and melting points of the carbon compounds. We will find that these compounds have low melting and boiling points as compared to ionic compounds. Chapter 3. We can conclude that the forces of attraction between the molecules are not very strong. Since these compounds are largely non-conductors of electricity, we can conclude that the bonding in this compound does not give rise to any ions. In class 9th, we learned about the combining capacity of various elements and how it depends on the number of valence electrons. Let us now look at the electronic configuration of carbon. The atomic number of carbon is 6. What would be the distribution of electrons in various shells of carbon? How many valence electrons will carbon have? We know that the reactivity of elements is explained as their tendency to attain a completely filled outer shell, that is, attain noble gas, gaining or losing electrons from the outermost cell. Versatile nature of carbon. We have seen the formation of covalent bonds by the sharing of electrons in various elements and compounds. We have also seen the structure of a simple carbon compound, methane. In the beginning of the chapter, we saw how many things we use contain carbon. In fact, we ourselves are made up of carbon compounds. The numbers of carbon compounds whose formula are known to chemists was recently estimated to be in millions. This outnumbers by a large margin the compounds formed by all the other elements put together. Why is it that this property is seen in carbon and no other element? Saturated and unsaturated carbon compounds. We have already seen the structure of methane. Another compound formed between carbon and hydrogen is ethane with a formula of C2H6. In order to arrive at the structure of simple carbon compounds, the first step is to link the carbon atoms together with a single bond and then use the hydrogen atoms to satisfy the remaining valences of carbon. For example, the structure of ethane is arrived in the following step. Step 1. 3 valencies of each carbon atom remain unsatisfied, so each is bonded to 3 hydrogen atoms given. The electron dot structure of ethane is shown in figure 6. Chains, branches and rings. In the earlier section, we mentioned the carbon compounds methane, ethane and propane, containing respectively 1, 2 and 3 carbon atoms. Such chains of carbon atoms can contain many more carbon atoms. The names of a structure of 6 of these are given in table 2: methane, ethane, propane, butane, pentane, hexane. But let us take another look at butane. If we make the carbon skeleton with 4 carbon atoms, we see that 2 different possible skeletons are filling the remaining valencies with hydrogen gives us. Will you be my friend? Carbon seems to be a very friendly element. So far, we have been looking at compounds containing carbon and hydrogen only, but carbon also forms bonds with other elements such as halogene, oxygen, nitrogen, and sulfur. In a hydrocarbon chain, one or more hydrogens can be replaced by these elements such that the valency of carbon remains satisfied. In such compounds, the element replacing hydrogen is referred to as heteroatom. Homologous series. You have seen that carbon atoms can be linked together to form chains of varying lengths. These chains can be branched. Also, in addition, hydrogen atoms or other atoms on these carbon chains can be replaced by any of the functional groups that we saw above. The presence of a functional group such as alcohol decides the properties of the carbon compound regardless of the length of the carbon chain. Nomenclature of carbon compounds. The names of compounds in a homologous series are based on the name of the basic carbon chain modified by a prefix phrase before of suffix phrase after indicating the nature of the functional group. For example, the names of the alcohols taken in activity second are methanol, ethanol, propanol and butanol. Chemical properties of carbon compounds. In this section, we will be studying about some of the chemical properties of carbon compounds. Since most of the fuels we use are either carbon or its compounds, we shall first study combustion. Carbon in all its allotropic forms burns in oxygen to give carbon dioxide along with the release of heat and light. Most carbon compounds also release a large amount of heat and light on burning. These are the oxidation reactions that you learned about in the first chapter. Addition reaction. Unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give saturated hydrocarbons. Substitution reaction. Saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagents. However, in the presence of sunlight, chlorine is added to hydrocarbons in very fast reaction. Some important carbon compounds: ethanol and ethanoic acid. Many carbon compounds are invaluable to us, but here we shall study the properties of two commercially important compounds, ethanol and Ethanoic acid. Properties of ethanol. Ethanol is a liquid at room temperature. Ethanol is commonly called alcohol and is the active ingredient of all alcoholic drinks. In addition, because it is a good solvent, it is also used in medicine such as tincture, iodine, cough syrups, and many tonics. Reaction of ethanol, reaction with sodium. How do alcohols affect living beings? When large quantities of ethanol are consumed, it tends to slow metabolic process and it to depress the central nervous system. This results in lack of coordination, mental confusion, drowsiness, lowering of normal inhibition, and finally stupor. The individual may feel relaxed without realizing that his sense of judgment, sense of timing, and muscular coordination have been seriously impaired. Unlike ethanol, intake of methanol in very small quantities can cause death. Methanol is oxidized to methanol in the liver. Methanol reacts rapidly with the components of cells. Properties of ethanoic acid. Ethanoic acid is commonly called acetic acid and belongs to a group of acids called carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as a preservative in pickles. The melting point of pure ethanoic acid is 290 K and hence it often freezes during winter in cold climates. This gave rise to its name glacial acetic